All right. Hello, wonderful people. Well, let's see what we got today. So, by the end of this lesson, you'll be able to graph functions using standard form, graph slope graphing slope intercept form, find linear functions x and y intercepts by graph or algebraically, determine if a pair of lines are parallel, perpendicular, or neither. Sorry, I'm just a little spacey today. I got that second vaccine thing yesterday, so it's kind of messing with me a little bit, but that's just a sign it's working. Anyway, so you guys have covered linear functions before in the past, and with these, it's just basically like the y equals mx plus b, straight lines on a graph sort of thing. So this is kind of a review from Algebra 1. So this is, again, more of a review than it would be of anything, but to understand functions, let's go ahead and kind of go back a little bit and talk about some of the other functions that we have covered. In this case, the linear function is usually the simplest one. So it helps to understand some of this before we go on to some of the more advanced stuff. All right, so let's see. When points on a graph lie along a straight line, this is called a linear relation. So again, straight line, that means linear. So linear means line, or line-like, I guess. Linear relations can be represented by an equation. For example, the equation of this graph is written as x plus y equals 8. So this is what we would call standard form. So standard form is in the form of, well, it's written right here. So we have a number times x plus a number times y equals a constant value. Or as we just say, ax plus by equals c. And in this case, it's 8. So you can see that it's crossing the y-axis at 8. So 1, 2, 3, 4, 5, 6, 7, 8. And the same is true this way here. It's also crossing at 8 along the x-axis. So that makes it, well, that makes the equation and this go together. And there's a little bit of rules about writing something in standard form, and that is a and b and c are integers. So before I go on, I'm going to explain by integers, it means that they have to be whole numbers, whether they are negative or positive. So that you cannot have fractions or decimals in the A area, or in the B area, or in the C spot. They have to be basically, again, whole numbers, either negative or positive. And so the next thing is a has to be greater than or equal to 1. So that means it cannot be 0. It cannot be a negative number either. So a cannot be negative or 0. And the greatest common factor of A, B, and C is 1. All right, so that sounds complicated, but really it just means like they're all in lowest terms. So it's sort of like a fraction. You would have to reduce everything. So like when we see a fraction, when we see something like 4 over 12, right, we have to reduce those numbers by their greatest common factor. What is the largest number we can divide from both of those numbers? In this case, it would be 4. So 4 divided by 4 is 1, and 12 divided by 4 is 3. So in this case, it's reduced to lowest terms. But here, A, B, and C, you can kind of think of it like a fraction that has 3 parts to it. It's like a 3-segment fraction. And it seems pretty complicated, but as always, I think once we get started on some of this and I point some of this out, it probably won't be as bad. So our first direction is to write each equation in standard form. So we got to look at some of these and think, why is it not in standard form? This should be in standard form right now. Okay, so there are 3 things that we got to watch out for. A has to be a positive number. So in this case, we have -5. So that means right now we got to take care of this negative right here. So this means that I'm probably going to have to times or divide. In this case, I'm going to divide everything by -1. So by dividing everything by -1, that's going to flip the sign on everything. So this 5 was negative. Now when I switch it, it should be positive. So positive 5x minus 6y, and all that divided by, sorry, all that equal by 12. I was about to say 12 divided by negative 1. So I think we're done with that. So let's look at our rules. Let's see, a, b, and c are integers, which is true. A is greater than or equal to 1. Okay, that was also true. We got that covered. The greatest common factor of A, B, and C is 1. So 5, 6, and 12, is there any number that we could divide all three of those numbers by? In this case, I think it's no. I don't think there are any numbers that we can divide, divide into 5, 6, and 12. So in this case, I think this one is in standard form. Let's go ahead and move on to the next one. Now, this one is written in what we would call slope-intercept form, but we'll talk some more about that later. And like I said, this is more of a review on some of these things. So what we're going to have to do is we're going to have to do some adding and subtracting from both sides. So I'm going to minus 2x from both sides. And remember, I got to make it go and look like this. So that means I'm going to have to put the x first. So I know some people on looking at this might say something like, well, couldn't we go like that? Which is true, that would work out. All the values are there and they're true, they're real, what they should be. But we got to make it look like standard form. So that means I'm going to have the x go first and the y is going to have to go second. And then we're going to have this c value here. So the c value means that it's going to be by itself on this side. Now we run into the same problem. Again, we have to make sure that x is greater than or equal to 1. Basically, it just means, again, it can't be negative or 0. So I'm going to do something. It's the same thing as this first one right here. Same thing. But for this one here, I'm going to times everything by negative 1. Just to show you that you can do something different. And again, this will have the effect of just reversing all of the signs we see. So 2x plus y. Oh, actually, we didn't reverse that one. So we're going to make sure it's a minus. So check your signs, make sure that they are all reversed. Which in this case, that looks like we got it. It's in standard form now. All right, let's see. This one looks like it, right? X, Y, regular number. But hold on a minute. This regular number is not by itself. Okay, it's got to be by itself on this side of the equal sign. So that means we're going to have to move this out of here. So I'm going to add 24 to both sides. And let's see, 9x plus 6y equals 24. And it is in the right form. It's in the form of ax plus by equals c, right? Our regular number is all by itself on the other side of the equal sign. So the order is correct, right? But we also have to check the other things too. X is positive and greater than 1, or at least equal to 1. So that's good too. But there is one other thing we got to do with this one here, and that is we got to make sure that the greatest common factor of all of these is 1. So in other words, we should not be able to divide this, all three numbers, by any of the same numbers, which if you look closely, you'll notice that 9, 6, and 24 can all be divided by 3. So that's what's going to happen. We're going to end up dividing all three of these numbers by 3. Because 9 divided by 3 would be, well, 3x. 6y divided by 3 would be 2y. And 24 divided by 3 would be 8. And there you go. So now this is in standard form. So you got to check all three of these numbers and make sure there's nothing we can divide by all of them. Okay, so let's go ahead and move on to the next one. So with this one here, looks like our x value is in the wrong spot. So we're going to have to move this one as well. So that means I'm going to likely have to add 7x to both sides and Don't forget X and Y are not like terms, so I should not be able to combine them. So 7x plus, and that's a positive 7y, so it's going to be plus 7y equals 7. Okay, so we got it in the right order. X, Y equal number. X is positive. That's good. Now we have to check to see if there's any number that we can divide all three of them by, and this one should be an easy one because, well, they're all the same number. All right, so it looks like we're gonna have to divide everything by 7 because, again, we have to have the lowest, we have to have the greatest common factor be 1, which means, again, we're gonna have to divide all of them by the same number. So in this case here, and I should have been boxing all of these. That's just what I have people do, so I know that they know the answer is here. And it also makes it a little bit easier for the grading. All right, now let's go ahead and look at this one here. So X, Y equals number. Okay, so it's in the right order. X is positive, so that's okay. So the third thing is we got to make sure that their greatest common factor is 1. And remember, oh, that's another thing. If you remember from the last slide, it says something about A, B, and C are integers, which in this case, these are fractions, not integers. So we got to fix that. So we got to undo the fraction. Now, if you remember that trick, we've been using this trick almost every week this whole time, the whole semester so far. And that is to look at your bottom numbers. So in this case, my bottom numbers are 4 and 3. And I need to multiply them by a number that can be divided by 4 and can be divided by 3. So in this case, that would be 12. So I times everything by 12, or if you want to be more specific, you can go with 12 over 1. Because what that's going to do is I'm going to have 12 times 3, which is 36 divided by 4. So 36 divided by 4 is going to be 9x. 12 times 1, so top number to top number and bottom number to bottom number. 12 times 1 is 12. And then 3 times the bottom number, which remember it was 1, would be 12 over 3, which means 12 divided by 3, which is 4. And 1 times 12 should be pretty easy because it would just be 12. Anything times 1 is, or just going to stay that number. So 12 is going to stay 12. And that looks like it's it. I mean, I can't see anything else that we would have to do. We already, well, I mean, we wouldn't be able to divide all three of them anyway because of what we did here with the fraction, because if they did have anything else different, but it doesn't hurt to check. Okay, so let's check it again, make sure there's no number. So in this case, 4 and 9, right? There's not really any number that will divide into 4 and 9. So that one's pretty much done. And it looks like we have another fraction for this last one here. So for this last one, I'm going to do the same thing. We got to look at our bottom number, which this one's a little bit of an easier one because, well, we only have one bottom number, and that's 6. So like I always say, every fraction has a weak spot, and that weak spot is the bottom number. So attack that bottom number, get rid of it, and you will no longer have a fraction. So same thing, 6 times 1 is, well, 6. 6 divided by 6 is 1, so I would say 1x. But actually, when writing the answers, we don't really need the 1. Okay, the 1 doesn't really say anything because we already know identity property is a thing. And remember, identity property states that anything times 1 is just going to be that same number. So in this case, if I have x times 1, it's just going to be whatever x is. Okay, and make sure I write all this in the same spot, so I don't want to shift anything. Well, not yet anyway. And it looks like we need to fix the order because y is on this side of the equal sign. And remember, we need x and y to be on the same side of the equal sign. So I'm going to go ahead and minus 6y from both sides. So I should get x minus 6y equals 12. Or is that? Oh, well, 6 times 2 should be 12 because I times everything by 6. Somehow I knew that, but I just didn't write it down. Ooh, yeah, that that vaccine can really, again, it just sort of makes you feel a little sick like you normally would. The normal things that happen when you get sick, you know, a little bit of a fever. That's why I don't have my jacket on today. Normally my class is really, really cold, and it works better that way. I'd rather be cold than hot. That's just me personally. Because I mean, if you're cold, you can always put on more clothes or a jacket or something. But if you're hot, you know, taking your clothes off is not always an option. Or if it's really hot, like if it's summertime in Phoenix and, you know, you're already hot and your heater or your cooler gave out and you're just sweating and there's no way to get out of it. That's just, that to me, that's misery. But yeah, my classroom's kind of cold, and I don't say anything about it because if I tell anybody my classroom's cold, the next day I'm gonna come in and it's gonna be like boiling hot, and I'm gonna have to like open some windows to let some heat out. Anyway, I'm just letting you know why I'm a little spacey today. Just a reminder. Let's see. Linear equations are often written in slope-intercept form. So this is the other way that we write linear equations, or again, line. Sometimes we call them line functions. But again, the word is line, so line, linear, it's the same word. Y equals mx plus b. This is probably what you're more familiar with. In most cases, whenever there is a line function, line graph, line equation, this is what I kind of prefer. And other teachers might be a little bit different, but that's, again, what I prefer. Or you could also say f of x equals mx plus b, and f of x, if you remember, f of x is the same thing as y, so we can exchange y for f of x, and f of x is a little bit more descriptive. It tells us more of what's going on because you can see the input and the output in the graph, right? So actually it would look something more like this. So f of x is, you're here, it's telling you the input is x and y is your output. So whatever you get on this side, that's your result, your x value. All right, so those are the two options that you can have. M is the slope. So slope is, usually it's the rise over run thing that you always see. So rise over run, how many times you go up and over, or sometimes down and over if it's a negative slope. And B is the y-intercept. And if you were in my class, which I think maybe some of you were in my class before for Algebra 1, I usually say that there's a way to remember it, sort of like with PEMDAS or anything else that you might remember. I think it's called a mnemonic device. Like for north, east, south, west, you might say never eat slimy worms or something like that. Anyway, the one I have for this one is yesterday I made excellent breakfast. So B is for begins or breakfast. So this is where your line goes, right? And the M, like here if you think about M, it kind of looks like a mountain. And mountains have slopes, which is why people go skiing on them. So that's the way you can remember it. And the X and Y, X is the input, Y is the result. So it's the same thing. Just a quick way to remember it. So slope is the constant rate of change between the point. And there's the rise and run again. So rise over run. And there are 4 types of slopes. And let's draw some of these kind of slopes. So we here in this first example, we have a positive slope. And a positive slope goes upwards. Now, it goes in the direction that you read. So just like you would read a book, okay, you would read a book from left to right. So if I start from this side, just like we did for our vertical line test, the line goes up, right? So you can imagine a person having to walk to the right, and he has to go uphill on that line. And then you also have the next one, which is a negative slope, which is pretty much the opposite. So instead of going up, it will go down. Now in this case here, once he gets to the top, like I said, the slope is like a mountain, up, down. So in this case here, he's probably able to go skiing or snowboarding, and he's gonna have to go down the slope. And again, it goes in the direction that you read anything. Read a book, read letters, read a sign. And then the other one is a zero slope. Oops, need my line tool here. So a zero slope, and I'm gonna write it a little bit, it can be above, below, or anything. I'm gonna put just below here. And that is, there is no slope. And this is the way most buildings are, right? So if you have a flat floor in your building, you don't want stuff rolling to one side of the house or one side of the room. So generally you want a zero slope, which means, you know, nothing's gonna just roll to one side of the house, one side of the room. So a zero slope is better for that. Now, these other two, they get confused with each other quite a lot because people confuse a zero slope with an undefined slope. So undefined is a little bit different. So again, you can ski up a mountain. You can ski down a mountain, or I shouldn't say ski up a mountain. You can, you know, certain mountain areas have flat areas like a valley or a plateau. But one thing that usually mountains can sometimes have is, in this case here, I'm going to put an undefined line, which is straight up and down. Now you can probably climb something like this, but you can't really walk up it. You can't slide down it or anything like that. All right. So most people cannot climb straight up and down vertical wall cliffs. It's just something that doesn't happen. So that's how you can think of it. All these three here, you can walk across them. This one here, you'd have to climb it. And usually if you want to climb a cliff, you're going to have special tools or special skills, but it's not something that everybody can do. And so those are the 4 types of slopes. And again, don't confuse zero with undefined. We're probably going to have some more examples on those. So I'll talk about more of those when we get there. So first, let's see, write the equation in slope-intercept form and then graph the line. Okay, so let's see what we have here. So this one looks like it's already in slope-intercept form. Y equals mx plus b. So that's it. Now we have to graph this. Remember, if you look in your packet, there's a rubric. And that rubric states that you must answer every question fully. Looks like this. You must answer every question fully, and that includes things like graphs, charts, tables, line, number lines. There you go. That's the word I was looking for. So anything that it tells you to do, you got to do those things too. So it's not enough to just work on this. So let's go ahead and graph some of these. So just like I was saying, yesterday I made excellent breakfast. Always begin your day with breakfast, okay? Even if you don't eat like a full Grand Slam breakfast from Denny's every day, you should at least have something, you know, toast, Pop-Tarts, something like that. Cereal if you have to. And different people eat different things, but you should begin your day with breakfast. It just works better that way. You may not always do it, but you probably will notice that when you don't have it. Now, so we begin at 7, and this tells us where to go. So again, m is like the slope of a mountain. It tells us whether it's going to be up or down or anything like that. So in this case here, I start from this and I go up 2 over 7. But that's going to take me off the graph. And I'm going to show you something else, and that is you can work on the slope backwards. Now remember, when we're working with integers, you might remember something like a negative divided by a negative is positive. So this means that we can go the other way. So this is just an easier way to graph. So instead of going up 2/7 where it takes me off the graph, I can go the reverse. So I mean, it would be like this, something like this. So let's count it out. So it'd be down 2, back 5. Now it's going to go through this spot right here. So that's where down 2, back 5 is going to look like. So I'm going to make it pass through that spot right there. Again, down 2, back 5. Now I'm also going to need the line to go through this way because you want to make sure your graph is all the way filled. Okay, so this line goes all the way through it. I'm going to mark some points off because I don't like seeing stuff that looks like this. Okay, these lines are not little wimpy lines that just go for a short time. Well, we would call those segments. Lines go on and on forever. So if you remember when we were working with Desmos, these lines go on and on forever. So do not just make little lines. In this case, I have a graphing tool that helps me out. So I'm able to make straight lines, but you could probably get yourself a ruler or find some kind of straight edge, like, I don't know, a student ID card, a credit card if you got it. Anyway, so let's go ahead and start with this one here. So begins. So it begins at 2. And then we follow the slope, which in this case, there's no number on the slope. So maybe I'll back up a bit and we'll find out what kind of slope that is. So here, my slope is -1. Because remember, if you don't see anything in front of a variable, it's 1. Now we got to turn it into a fraction. So this means -1/1. Now I don't put a negative here because if I put a negative here, that would actually change it to a positive because negative divided by negative is positive. And we don't want to turn it positive. We want to keep it true to what it is. So this means that our line, so we know where it begins, now we need to know where it goes. So this means down 1/1. So down 1/1, down 1/1, down 1/1. And if I keep that pattern up, I should get something like this. Now I just got to go back through this point and back the other way. So make sure it's still going through the same, oops, a little bit more over there. There you go. And there you go. My line is going all the way from one side to the other side. All right. None of these little wimpy lines that look like this. All right. I'm not going to accept those because that's not the way lines are. That's not an accurate representation of what a line is. So use a ruler if you have to get that line all the way across. Okay, now let's do this one here. So let's see, x plus 3y equals -15. So we're going to have to make this look like y equals mx plus b. Now you can graph this using standard form. It can be graphed, but well, it says in the directions. So anytime you got to work on something, work on the directions. Actually, in this case, I want to get rid of this x because 3 is already on that side. So I'm gonna have to x on both sides. So this would be 3y equals -x. And you got to make it look like y equals mx plus b. So some people might say, well, couldn't we put -15 minus x? Which is true. And again, the values would be correct, but we want to put it into the form of y equals mx plus b. Okay, now I got to get this y all the way by itself. We got to solve for y. So y equals, now here, remember, we have a 1 in front of this x. If you see a variable by itself, that means it's going to have a 1 in front of it. Now it's a -1 because there's a negative there. And now x is kind of free to be its own thing because we have our fraction, which again, with our slope, it's good to have a fraction. We want a fraction because then we can easily spot the rise and the run. And this is going to be negative 15 divided by 3, which is going to be 5. So now we know that our line begins at negative 5, which is a little bit lower than that, it looks like. 1, 2, 3, 4, 5. There you go. So we know our line basically begins from here. Or again, it's a y-intercept, so that's where it crosses the y-axis. But again, it just makes more sense to think of it as the beginning. So let's go ahead and see where this line goes. So follow the slope, down 1 over 3. Down 1 over 3. And this slope is negative, so the line should go downwards as we move left to right, which it does. Now I just got to go through that same point and extend that line all the way to the other side of the graph, which it looks good. And double check your slope, okay? Because this is like the biggest thing that always happens. All right, I'm going to be checking a paper. I'll be looking at, grading something, and all of the lines are going up. And I know at that point they're not checking the direction, the cardinality. They're not checking to see whether it should be a positive or a negative slope. So some slopes will go up, some slopes will go down. You got to make sure you know which way it's going and double check yourself on that too. Remember, there are certain things that we've been double checking ourselves with. Like seeing which way the mouth on the inequality opens, those sort of things. We got to keep track of them because they are tricky. They will constantly be something that you're gonna have to worry about. All right, so I have two things to move in this case because I want to get this y by itself, and I could just move y by itself, just minus y from both sides, but then I'd have a negative y. But I don't want a negative y because then I'd have another step of having to undo the negative on the y. So now we got rid of the 4x by minusing 4x, so we get negative 4x on this side. And here I have 1, which 1 plus negative 1 is going to cancel that out, but I'm adding 1 to both sides, so that's going to move it over to this side. And there we go. That's it. We got everything we need. We can look at our slope, and you can turn it into a fraction, just like when we were adding, subtracting, or multiplying, or dividing fractions. You can turn it into a fraction by putting a 1 under it. By putting the 1 under it, it becomes a fraction, and in this case, now we can see that it has a run of 1. So let's go ahead and start with our y-intercept, our b value, the begins. So here I go to plus 1, which is up here. And now I got to go down 4 over 1. So again, from this point, go down 4 over 1. Down 4 over 1. But I have to do the same thing back the other way. And if I want to go backwards again, reverse both of them. Negative 1, up 4. Negative 1, up 4. Because again, if I'm looking at the slope, negative 4 over 1 is the same thing as 4 over 1. Negative 1, sorry. So if I look at this one here, up 4, back 1, up 4, back 1. So you can switch the signs on some of these slopes if it helps. In fact, I highly recommend it. And again, this is sort of a review, so I'm going to be going through this a little bit faster because this is like when you're talking algebra 1, this is like literally a quarter of the entire content in algebra 1. But I also understand that well, I guess considering everything that's been going on, I think maybe it would be likely, I guess, that we'd have a lot of this stuff forgotten. I don't know. But I'm still covering it. So let's move on to the next thing, and that is vertical and horizontal lines. So we remember how I said that there's two different kind of slopes where it seems kind of weird and they're confused with each other. So vertical means up and down. Horizontal is side to side. straight side to side. So this one's vertical. This one is horizontal. An easy way you can remember this is when you see the sun set or sunrise, it goes beyond a horizon. So horizon, again, means sideways because, you know, you'll watch the sun go down and it goes behind the horizon. Or if it's going up, it's coming up from the horizon. So it wants us to write an equation. So this one, again, is a little bit of a tough one. So whenever you are missing, so just a quick recap, y equals mx plus b, that's going to be something that we're going to, anytime you're talking about lines, you know, that's like something you see all the time. So if we look at where the b value is, where is the b value? Where does it cross the y-axis? So in this case, it does not cross the y-axis. Now here's another thing that makes it easy to remember. If you are missing an x or a y, then it doesn't touch that axis. In this case, it does not touch the y. So this means that there is only an x. You can also think of it as a number line. Remember, we've been working with number lines with 0 in the middle, and then there's negative numbers on this side and positive numbers on the other side. Negative and positive. So it's the same thing. It's just like the number line is right here. So an x would go sideways. So that means, you know, if I have to go to -3, that's where my line crosses the x-axis. It crosses at -3. And we're missing the y because it doesn't cross the y-axis. And the same is true with the other direction as well. So in this case, I have a horizontal line, and there is no x value because it doesn't cross the x. So this means I'm going to get y equals one number, which in this case we have 1 or equals 1. Right? Y just plain out equals 1 because there's no x-axis. There's no slope. Just like I said, a good building shouldn't have a slope. You wouldn't want to live in a house where everything rolls to one side every day. You know, you drop a marble, drop a quarter, drop a can of Pringles or something. It's always going to roll to one side of the room. It's best to just have everything not roll around. So again, don't confuse these two things together, and that's just the easy way to remember it. If it's missing an x or a y, then it means it doesn't touch that axis. All right, parallel and perpendicular. So this means that there are two lines. There are two lines on a graph. So if you have two lines on a graph, if they have the same slope, they're going to kind of be going in the same direction. If they are perpendicular, and I'll probably explain some more of this when we see some examples, but a perpendicular line is one where they kind of cross in an X shape form, but the X is actually like, it's equal on all four sides. So it crosses at a 90-degree angle. And the important thing is, again, with perpendicular lines, the slope is what we call opposite and reciprocal. So opposite, in this case, refers to the sign. So that means if it's positive, it will be a negative. If it's a negative, it will be a positive. So you switch the sign, and that's what it means by opposite. And reciprocal. So if I have a fraction of a over b, it will become b over a. So we have to do two things: switch the sign and switch the fraction. Switch the sign and switch the fraction. So determine whether these lines are parallel, perpendicular, and sometimes they will be neither. So just looking at what we have here, well, it's kind of hard to tell whether it's going to be, it's hard to tell what the slope is, because in order to know the slope, we have to put it into slope-intercept form. That's why it's called slope-intercept form, because you can easily see the slope. So we got to solve for y. So get that y by itself. And I'm just doing my regular algebra stuff. I minus 10x from both sides so that I can have 10x on this side. And I need to solve it completely for y. So that means that 5 has to go. So y equals negative 2x plus, and then 5 divided by 5 is 1. 10 divided by 5 is 2, so don't forget the negative, so that'd be negative 2x. Now, if this slope is negative 2x, then it should be parallel. In order to be perpendicular, if it was perpendicular, now you don't need to do this every single time, but it would be the opposite. So it would switch from a negative to a positive, and then we would have to switch the fraction. So I'm going to put a 2 underneath because 2 over 1, 2 divided by 1 is still 2. Flip it. So it becomes 1/2. So the only way that this would become perpendicular is if it was a 1/2. Now, 2y, so y is already on this side. So I'm going to do something a little bit different this time. I am going to minus 16, and that makes y on the right side, and that's not something I normally do. But I'm going to use reflexive property and just switch the sides that everything is on. So on this side, I only have 2y because this canceled out. But on this side, I'm gonna put negative x, and I'm not changing the signs or anything. Everything's just staying the same. And it looks like I'm gonna have to erase this because I'm gonna run out of space here. And then divide everything by 2. And that's gonna be y equals negative 1/2 x minus 8. Now this y-intercept, our b value, doesn't matter at all, okay? So that just plain out doesn't really matter. Now, I erased it, but was it half or negative half? So what is this? It's a reciprocal, so 2 has been flipped. So instead of 2 over 1, it's 1 over 2. But they're not opposites. Okay, and we can confirm this as well. We can use Desmos and confirm it. In this case, this would be neither. I almost put a GH in there, like the word light or night. But this is the important thing. It's asking what type of lines are these. So in this case, this would be neither. Okay, so I'm going to go ahead and start on this next one. And this is, again, just some plain old algebra stuff. And I got to get that y out of there by itself. So y equals, a negative divided by negative would be positive. And then I have to reduce the fraction. So reduce the fraction. And then 42 divided by 6. Okay, that would be 7. Okay, but actually that last part's not really that important. But I guess it's good practice for solving stuff. This one looks like an easy one so far, because I only have to, the y is already by itself, but I have to get rid of that negative 3. So this would be y equals negative 3. Ooh, now hold on a minute. This one's not in the right order. It's not in y equals mx plus b. The x value should go first. Now we could write it. In fact, you know what? I'm going to do it. I'm going to do it. Because I think you should get into the habit of always putting it into the right form. Okay, now looking at the slope here, I have 4 over 3. Over here, I got 4 over 3. So the slopes are a match. They are exactly alike. So both lines are going up 4 over 3, up 4 over 3. So you're going to have it's going to be a little bit different, but they're both going to be kind of pointing in that same direction. Well, actually. So that would be parallel. And one way you can remember parallel versus perpendicular is parallel has 2 L's that are parallel, actually 3 L's that are parallel. So the word kind of looks like what it describes. Sort of like bed. It looks like what it describes. Anyway, let's go ahead and move on to the next one. And again, this is just some basic algebra stuff. I'm going through it a little bit faster. Hopefully by now you're an expert at doing basic algebra. You know, you've already been through about 3 years up to this point, maybe most of you getting math all out of the way. So anyway, so I divide both sides by 8. So in this case, I just have y equals x. So there is no b value, which sometimes that happens. Sometimes you do get no b value. And if that happens, that just means your line goes through the origin. So it would go right through the middle like that. So my line would go right through the x and the y axis. Okay, nothing wrong with that. Let's see what we got here. So I got to get that y by itself. So this means the x has to go. Negative y equals negative x plus 4. And then I'd have to divide everything by negative 1. Y equals x minus 4, because a negative divided by a negative. And this should help me identify what, again, the slopes are. So just looking at the x, that's the only important thing we got to look at is just the slope. So in this case, both slopes are 1. And that means that these are parallel because the slopes are matching. Okay, so with this one here, we have 2 lines. I have x equals 2. So, and for this one, I'm going to graph it because that way we have a little bit of practice graphing these, because I know, again, students will always confuse these 2 things, which actually it doesn't really help in this case because they're both 2. So anyway, graphing the first line here, x equals 2. So x-axis, go to 2. And remember, if it does not have a y, that means it will not pass the y-axis. And then for this one here, I have y equals 2, which again doesn't really help. I was just talking about confusing and clearing up confusion. So it doesn't really help when I have the exact same thing on both of these. So go to the y-axis, go to 2, and we need a line that does not touch the x-axis. So even if it's a little bit like this, it is going to touch eventually. So it's got to be perfectly horizontal. And parallel, and I'm pretty sure if you're working on any type of problem, how you can tell if something is perpendicular is grab a sheet of paper. Okay, so in this case, I'm going to use one, just to kind of show you. So this is the packet that you were given. Use the corner, okay? Corner of papers are 90 degrees. So I don't really have a paper for us to grab. So I'm going to go ahead and just make one. So grab a piece of paper like this and fit it into the corner of your line. See how it fits right in there? It's a 90 degree. So grab that paper, and you can do this at any angle, okay? Just fit a piece of paper. As long as your graph is really well made, as long as you use straight edges, shouldn't be a problem. Just use a piece of paper, or even sometimes you can just sort of use your judgment and tell whether it is going to be parallel or perpendicular. So in this case here, it is going to be, perpendicular. And I noticed I just didn't box this one either, so I was probably in a hurry to get to this one. Okay, so that's kind of a bit of stuff to cover. I don't want to break this lesson into 2 different lessons because, again, to me, I kind of consider it a review. So I'm going to try to finish this in the next 20 minutes if I can, because we still have 20 minutes of class. So now we're talking about x and y intercepts. So let's go ahead and read this. The point at which a graph intersects the x-axis is called the x-intercept. So even with that last one, remember I said that we look at the x-axis. So look at the x-axis, see where it crosses Our first one crosses right here at, so looking at the ordered pair, the coordinate -3 and 0, which actually I just have it right there. So that's the first one is -3, 0. The other one is up here, and this one here, so again, x and y coordinate. So x is 0 because it does not move sideways. It just goes up 4. So 0, up 4. And that's where this one is, which is actually, again, this one here. So those are the two x and y intercepts for this graph, which again, I have them right here. Now, x-intercepts are a little special. Well, I guess I should say important. And as a result, when something is important, there's a lot of words for it. So an x-intercept is also called roots, 0, or solutions to an equation. And I don't know why they picked roots. Like, I don't know, I've been doing math stuff for 10 years and I don't know why the word roots is a thing. Like, why did they pick roots? I mean, like when I think roots, I think of like trees or carrots or something like that. But I don't know why they would pick something like that. 0 makes sense. Okay, so like if you were to zero out an equation, it will end up going to the intersection, the intercepts. But either way, I mean, even though I don't like it, that's still what it's called. Now, how do you find these? So algebraically, looking at the graph, we were able to just look at the graph, point, and say that, okay, it's going to cross right there. So this is the one I call taking turns. So again, if you were in my Algebra 1 class, I call this one the taking turns. So it's sort of like if you're, I don't know, like let's say you have an important meeting to go to, you and a friend, and there's no mirror and you're in a hurry. So it sounds weird, but you know, you don't want your hair to go in, to be messy going into a place. So sometimes you'll check on each other, and you know, you might look at someone's hair and be like, okay, you need to, you know, brush this part back here, or, you know, check that side and make sure it's going to the right place, because you don't have a mirror. You can't see yourself. So in a way, it's sort of like you check me, I check you, you know, you tell your buddy, you know, hey, you got some gum on your pants or something like that. You know, you don't want to look like a weirdo going into a meeting like that, or a presentation, or like a safety check. You know, if you're riding motorcycles or something, you might want to, you know, if you notice that your buddy's bike is smoking, you know, you can tell him, hey, you know, I'm watching out for you, and he'll probably do the same for you. Anyway, so to find the x-intercept of an equation, set y equal to 0 and solve for x. To solve the y-intercept of an equation, or to find the x-intercept, set x equal to 0 and solve for y. Use these points to graph the equation. So for example, they want us to find x and y intercepts for this equation. So, okay, so to find the x-intercept, the first thing we got to do is, so if I want to find out the x, and you don't really need to write this part down every time, but I would suggest if it helps, you do. So y is equal to 0. So write this down, but I'm going to substitute 0 in for y. There you go. So it's the same thing, but y is now 0. And I'm going to add 2x to both sides, just using my basic algebra. So now I have 2x equals 5. And it looks like I'm going to have to divide both sides by 2. And this one's an easy one, because if you had $5 and you had to split it exactly even into two things, you know, you would say 2.5 or 2.5, which in this case, I'm just going to go with 2.5 or 2.5 because we're graphing it. All right, and that's how you find the x-axis. So I know x is crossed at 2.5. And here it says the second part, to find the y-intercept, take x and set it equal to 0. So y stays now. However, x has been replaced with a 0. So that means -2 times 0. Well, anything times 0 is going to be 0. So that number pretty much just drops out entirely. It's just gone because it's 0. We don't need to add 0 to anything. And again, that's identity property at work. So y equals 5. So now I know in this case here, I have both x and y intercepts. Now for this one here, it wants us to put it into an ordered pair. So x and y, x and y. So x value here is 2.5, and that's why I put it into a decimal, so it makes an ordered pair a little bit nicer. And then over here, the y value should be 5, because that, again, it says y equals 5, so I put it in the y area. And x is 0. And if I really wanted to graph it, which I'm not going to right now, because if I graph it, then we're gonna be working on that in just a minute here. But those are the two intercepts that we're looking for. All right, so let's practice finding some of these intercepts. So finding the x-intercept is usually the first thing. So this means that y equals 0. So I'm going to take this and put in 0, for y. Now, actually, in this case here, I think I'm going to add 1. I think that'd be a little bit easier. So I get 1 equals 5x. Divide both sides by 5. Now, x is by itself, so this should be my x-intercept, which in this case, it looks like we're going to have a fraction. We can put 1/5, which in this case, I'm going to put 1/5. You could use a calculator and you would get something like 0.2, but it's okay, no problem. In fact, I can even graph it with 1/5. So if you imagine this little mark here between 1 and 0, split that into 5 and then mark it to the first one. All right, so for the next one here, let's go ahead and imagine that x is equal to 0. So now it's the other guy's turn to inspect the other guy. So let's see what happens if there's an inspection on this guy here. So in this case, I get y equals -1. So actually that one was a lot easier because in this case, I just get y is equal to -1. And to graph it, I'm going to put it right there on the y-axis at -1. All right, this is going to be a tough one. But actually, I can also follow the slope here a little bit. And it may not be exactly perfect. And it doesn't need to be, if I'm grading this, if I'm grading the work, I'm not going to be grabbing a little magnifying glass and saying that's not crossing exactly. So if your line just looks just like this or even close to it, I'll take it, I'll accept it. Now I need to fill in my ordered pairs for both of these. So again, every ordered pair has an x and a y axis, or sorry, an x and a y coordinate. So x is 1/5, and that would be 0. And then the y value would be, well, if I want to know what this number is, again, we don't move sideways. So the x is 0, and then we go down 1. Whew. Yep. All right, so that's it for that one. Let's go ahead and move on to the next one. All right, let's see what we got here. Okay, y equals 0. And it doesn't really matter which one you find first, as long as you find both of them. So you could easily look for the y-intercept first, and it wouldn't really be much of a difference. But I'm just going with what the direction said. The direction said, do this one, then that one, but really it doesn't matter. All right, so let's see, I have -6/5x plus 2. And I got to get rid of this here. Now, I'm going to multiply it by the reciprocal. So this is a trick I have used, but I don't use it all that often. Usually I kind of say, let's do one thing at a time first. But here I'm going to get rid of both of the, actually I'm going to get rid of 3 things. I'm going to get rid of the negative, I'm going to get rid of the 5, and get rid of the 6. But whatever I do to one side, I have to do it to the other side. So I multiply both sides by the reciprocal, not the opposite, because I'm not trying to change the sign. But negative times negative cancels the negative. 5 times 6 is 30. 6 times 5 is 30. 30 divided by 30 is plain old 1. So let's see, I got 0 for y still, because y is all by itself and y is equal to 0. And in this case, let's see what we got. We have negative 10 divided by 6. Okay then. X equals, I'm gonna add 10 over 6 to both sides. I'm also gonna reduce it so I get 5/3. Okay. Now 5/3, or in this case, I would rather say let's do a mixed number. So instead of 5/3, okay, so 5 divided by 3 is 1. 5 minus 3 is 2, and 3 is the bottom number, so it stays the bottom number. So graphing it, this makes more sense. Because now I can see that it's 1 2/3, which 1 2/3 is about right there. And again, it doesn't have to be precisely there. As long as your graph, really as long as your graph is pointing in the right direction, in roughly the right direction, I'll accept it. You know, you will get full points for that. Okay, now we need to have x equals 0. So y equals 6 over 5 times 0, which it doesn't really matter because all that's going to just be if I multiply anything by 0, it's just going to be 0. So y equals 2. So mark out 2, and then just use a ruler if you can find something that will go through both of those points. Nice and easy, and I was able to get it on one shot without having to go back. Okay, that just goes to show how awesome I am. Okay. So it looks like we have a few more of these, 1, 2, 3 more pages. But again, just take turns having x and y be equal to 0. That's all we need to do. All right, so for this one here, it looks like I'm going to have to use, well, let's take y equals 0. So we're going to open up that possibility. What if y equals 0? And I'm gonna minus 3x, or actually I gotta get rid of the minus 3x, so that means I'm gonna have to add 3x to both sides. So 3x equals 16 over 3. Now I'm gonna have to divide both sides by 3, but there's gonna be a problem with this one here, because I can't just divide this, because otherwise I'd have a 3-layer fraction, and you honestly can't have that. Okay, no can do. Now there's 2 ways to do this. There's kind of an easier way, and I'm going to stick with the easier way because the easier way is probably easier to remember and easier to work on without remembering a whole bunch of rules or risk taking the wrong step. So we're going to use that same trick to get rid of fractions. Look at your bottom number and times everything that will divide by that bottom number. So in this case here, I end up with 9x equals, and then this should be 16. Because 3 times 16 is like 48 or whatever, and 48 divided by 3 is 16. Basically, you're just getting rid of that bottom number. So if I times everything by 3, that gets rid of it. And you could multiply it by the reciprocal, which again, that's a whole different thing, which we didn't cover. So that's why I didn't want to go over that one, because that method requires you to have to know how to divide fractions. And right now is not a good time. So this equals 1. All right, so 16 divided by 9, you can just use your basic division like this. It goes in there one time, you get 9. 16 minus 9 is 7. So 7 left over. So 1 and 7/9. Okay. And now we got to do the other one. So let's see, y, oh wait, no, we already did what happens if y equals 0. Let's do what if x equals 0. And I'm going to just draw a line here just so that way we're not mixing these two things together. So y equals negative 3x, but x has been replaced with a 0. And here I have 3 times 0, which, well, actually it's negative, but that wouldn't matter at all. And I get y equals 16 over 3, which, again, we are dividing it, so it's and graphing it, so it's much better to have a mixed number. So 16 divided by 3 goes in there 5 times. Closest we can get to go without going over is 15, which means I have 5 and 1/3. So y equals 5 1/3. Now there's also one last thing I need to do, and that is to move, I'm gonna move these out of the way really quick. And that is to type in the, well, in this case, I can't type it because if I type it, then I will have a, I can't really do the fractions, which I like to type things, but since we're dealing with so many fractions, it's better to just write them. So I need the ordered pairs. So for x value, so again, this is our x, so 1 7/9, 0. And then for the y value, remember the y is the second number, so this would be 5 1/3. So 1 7/9 is over here, that's the x value, and then over here the y value is 5. So 1, 2, 3, 4, 5. And 1/3 is a little bit higher than that. And again, your graph doesn't need to look exactly like this. I understand that sometimes it's just tough to get it exactly on point. But again, these are the intercepts, sorry. Okay. Oh, yeah. These are actually a little bit more work than I might have thought. Well, they're throwing a lot of fractions and stuff at us, that's why. If there weren't so many fractions, this would probably go a little bit faster. Now this one's a little bit of a weird one because if we check it out, y is by itself. Actually, it's in standard form, so x and y are on the same side. Now this actually makes it a little bit easier, and this is how you graph standard form. So if you're graphing standard form, this is exactly what it's going to look like. So I'm going to ignore the 0. And just divide both sides by 4. And that would be x is equal to 2. So I can tell it's going to go right through here at 2, 0. So over 2, not up or down because it's a 0. And right here I have x equals 0. So what would happen if x was equal to 0? Well, I'd have 4 times 0 minus y equals 8. And again, just the same thing. We're just replacing x with 0. So this would be negative y equals 8. And I would just need to divide both sides by negative 1, which is all it's going to do is switch the sign. So y equals negative 8. So to get that one, I would just ordered pair negative 8. So that means I don't go sideways. X value, right, tells me don't go sideways. So I'm going to just go down 8. Which actually it looks like this graph bottoms out at negative 8. Do our best to draw the line across. Now I only have one more to go. And the bell's going to ring in about a minute or so. So we might go a little bit over. But I think we only got like one more to go. So let's try our best to get this done. All right, I'm going to go kind of faster on these ones. So just replace that y with 0. And over here, I'm going to replace x with 0. And I'm gonna again going a little bit faster. This is negative 4 times 0, so It's basically just means ignore it. So 5x, and then this whole part's going to drop out. And then divide both sides by -5. Negative divided by negative is positive. And 24 divided by 5 is 4. I'm going to have 4 left over, so this is 4/5. And then over here, I'm going to have -4y equals -24, which in this case, 4 divides nicely into 24. Negative divided by negative is going to be +6. So in this case here, I got 4 and 4/5, 0. And then here I have, oops, that does not go in the X, it goes in the Y area. Yeah, so let's go ahead and put this in there. Actually, I think this goes, anyway, I just looked at the packet. I just noticed it goes to 7. So I'm going to just stop at this next one. Whatever happens, I'm going to stop at this next one. So 4 and 4/5 is going to be about right there. And 0.6 is going to be right there. And make sure that we got them in the right spot. Run a line through those. And then we're done with this one. And I'm going to see if I can hurry up and get this next one before the second bell rings, in case you have a second hour to go to, or your next hour to go to. Oh, okay. I'm thinking before anything even happens on this one, I'm going to take a shortcut and I'm going to times everything by 12. And the reason I'm going to do that is because I want to get rid of all these fractions. So 12 times 3 is 24, 36. 36 divided by 4 is 9x. Plus, and then 12 divided by, in fact, that'd be a negative. So 12 divided by 3 is 4y equals -24. And this allows me to have a much easier set to deal with. This way I don't have to deal with any fractions, because you notice that sometimes on some of these I do have to deal with fractions. But before we even start, I'm putting it in standard form already. So remember, standard form, x has to be positive. It has to be greater than 1. And there cannot be any fractions and all that stuff. So in this case here, actually, in fact, I think this is an exact example of something we've already done before. Anyway, check my signs. Everything looks good. So y is equal to 0. So I get 9x equals -24. And for this one here, I get -4y equals -24. Now, I already know that 9 times 0 is going to be 0, and I don't need it here. I know that if I have y equals 0, -4 times 0 is just going to be gone. So I just ignore it. Now, if you have to graph a lot of standard form, this is what you do. You just ignore it. Okay. But if it helps, write it out. Definitely, you don't want to make a mistake. So let's see, x is 24 divided by 9. And that's going to be 2 points. It's going to be a fraction. I'm sorry, not a fraction. It's going to be a repeating number. So actually, I can't do that. I cannot use a calculator on this one here. So I'm going to have to actually find out what the actual thing is. So then in this case, it would be 2 2/3. And then for the y value, so 24 divided by 4 is actually going to be 6. Actually, not right, because the last one is also a 0.6. So y equals 6 and x equals 2 2/3. Yeah, 2 2/3 of, like, I can't write that out as a decimal, because normally we don't put repeating decimals inside of ordered pairs. I mean, you might find examples of where it's been done, but it's just something we don't normally do. So last thing to do is graph it. So mark out 6 and then 2 2/3. So it's almost a little more than 2.5. Can't get this right. I'm just hurrying along. That's why. Put that line between the two of them. And there we go. So that is it. Okay, I did as much as I could, as much as, a little bit over time, but it is what it is. Anyway, that's it for today. That'll be it for today. So bye-bye.